Just to introduce myself, I've been working with Flipkart since 2015. I joined as a network engineer there, and today I lead the engineering team there. I've been in networking for 13 odd years now, and yeah, it's been quite a ride. So happy to share some part of that today. Today we'll look into what our journey has been, and our has been some journey over the years, the way Flipkart has grown and has become one of the bigger startups in the country, and that has definitely been by the infrastructure that has powered it to be where it is something that I wanted to, the essence of that is something I wanted to capture today. And with that, we'll look into what is how we look at this whole on-prem versus cloud thing. By the way, we are there on both. So for us, it's a hybrid thing. But there are, like I think in Puvi highlighted, that it's a very subjective matter. It's completely based on the business itself. What works out best for the business in terms of the requirement, cost, all of those things. And then we'll look at what goes into building a data center. And it's quite an effort if you have to go bottoms up and build something ground up. And then some high level view of what does network in a data center looks like. And then we'll see how the complete flow of how a Flipkart customer gets what he wants from our website or our app. So it's been quite a journey. We started as a company in 2007, and it was all good. And we started as a cloud or a managed services when we began. And the first data center we had of our own was in 2012, and this was a typical three-tier architecture. We realized we're growing big, and we need to have certain needs of ours satisfied by building our own infrastructure and the managed services. And the more reason, if I could think, was because we were hosted at that time outside India, and that's where the buzz started coming up, and Flipkart started gaining traction within India. And then being local was one of the main reasons at that point when we decided to have our data center, and that's how we began that journey in 2012. And I think the paradigm shift that happened, I'm sure most of you must have experienced at that time, the first big billion day, and that was groundbreaking when that happened. And nobody at that point expected it to be what it had become that day. And that in itself was a beginning of another journey. That's where we realized we have grown really big, and there has to be a paradigm shift in the way we're thinking, our infra, our app, the whole business, and everything. And that's where we built our first highly scalable class design based data center in 2015. And that was some journey indeed, because that was completely a shift from how a traditional network is built. And I think we were one of the first companies in India to even take that stab at building a class design data center. We'll talk a bit about that in the coming slide. And yeah, to sum it up, today we have 4 generations of data centers that we have built, and we have evolved from being a 10G network to a 40G to a 100G, and our latest deployment, which was in 22, we have built a 400 gig network. So this is to show what the ecosystem looks like. It's an e-commerce company, and there are certain pillars that drive an e-commerce company. So as you can see at the top is your that's India trying to shop on Flipkart, and at the bottom you see are the pillars of ours or any e-commerce company for that matter. So the app and the website that you see on the top is what we call the user path. That is where all the users come and do the shopping. But once the shopping part is done, then there's a complete supply chain, and we are one of the biggest supply chain in India. And that's where we have this SCM, which is the supply chain. Then we have the field executives who are the ones responsible to deliver. And then we have the customer care. So these are the main pillars of our ecosystem. And all of this is powered by the middle layer that you see, which in the middle is the FCP, that as we call it. It's Flipkart Cloud Platform, and that's where all the magic happens, and everything gets connected in that manner. And then we have some presence in public cloud. It's a small presence, so you see a smaller cloud there. And then there are key infrastructure components like the CD and DNS, which further helps drive this purpose. So yeah, I think on-prem versus cloud. It's to begin with. I think it's really not a versus thing. Both have their own set of advantages and disadvantages. It's definitely a call of the business and what works out best. But we've had our hands on both, and we still have our hands on both. And for us, it's a hybrid model that we follow, and we have a certain workloads or use cases that we run off cloud, and there are certain things, or the majority of our stack, which runs on our on-prem data centers. And I've just listed the top three that I felt are the biggest plus of each of the site. So economies of scale, this really works out well for us. And when we have to build, a data center which can have tens and thousands of servers, which translates into hundreds and thousands of compute capacity, storage, building platforms on top. All of this, when we embarked on our first journey in 2015, we did have our set of trying to see what works best for us, and the kind of scale that we are looking at. This really is a winner, and that's where economies of scale really works out very well for us when we build our data center. And that's a cost part. But if you have to talk about the whole setup itself and how the infrastructure powers our business, that's where this is a very integrable and customizable setup that we have. So integrable and customizable, when I say it, it's more of the kind of requirements that we have and the kind of products that we have built over the years. It's not something we envision. Oh, this feature will bring 2 years down the line or 1 year down the line. When we have to make those big jumps, it's all monthly targets, and businesses spawning maybe in 2 months, or we go and buy a company which comes and runs off our data center. So everything happens in a very quick time, and that's been one of the reasons for our success, I would believe, right? And that's where when we build these data centers, it's we keep into account all of these things when we start our journey. And then how easily can stuff be brought in, how can we change requirements, and even for that matter, one of the top things I think everybody follows is the security, right? And everything has to be revolved around that. And there are a lot of evolutions that have happened in the security, the compliance world, and we have to be compliant and we have to be secure in all those aspects. And that's where this has really helped us, because everything is in our control. So I would summarize that by saying we have a better infrastructure control when we have our own data centers. And for me, what tops all is the ease of operations, because since everything is in our control, any issue, any debugging, any triaging of incidents, everything, we have our team. And then at Flipkart, the platform team as a whole, we are 200 plus engineers, and everyone comes together. And it's all the fact that we know whom to reach out to, how to go about fixing, as really works out well. As opposed to when we are on cloud, we can only raise an issue, and then it's up to the provider to try and fix it, and we just wait and watch. So, and we have that is something that is a major plus for me when we have our own setup. And but at the same time, cloud has its own benefits, and I think Purvi touched base upon this as well. That is time to market, right? If you want to start a company tomorrow, you just take 2 instances and run a website there, right? And that really helps. You won't go around looking for your own data center. And then the option of scale as you grow, and this is something we also use. The nature of our ecosystem is such, when we have this flash sales, or we have our big billion days, right? So our traffic is always a spiky kind, where we have our BAUs, which is at a certain level, and then there are our flagship sale days or any other requirements that we have. And at that time, we might need some extra capacity, so we can't go about building a new data center just to satisfy that. So that's where we would lean on cloud to scale as we grow or as we have a requirement. And then, of course, the off-the-shelf products that you get from cloud, be it a pass offering or be it some security offering, all of this, if you have to build something ground up within an organization, it takes time, and it has its own lead time. But that's where cloud, a lot of problems are solved there already, and you can just buy them. So that's an added advantage of cloud. But yeah, if I have to summarize this, I think it's a business driven approach that it would be, and in our case, we have taken the hybrid route. Right. So what goes into building a data center, and it's a mammoth effort when we start doing it, and it starts from deciding what is it that you want in terms of the space. If once you decide, okay, we're going to have a data center, you first start by identifying the provider who will build that data center for you, and then the kind of the place or the kind of data center that you want, right? And if you look at the green field versus a brown field, green field is completely bottom up setup that comes up as per our requirements, where we can work on every aspect of the data center that we need, right? And they will design it per our need, but that comes with a lead time, because now it's just an open ground, and they have to build everything up there. So there's a lead time associated with that, as opposed to if we don't have that much time in hand, and if you want to spawn something in the next 6 9 months, and if you're looking out for a partner, that's where we can look at already built data centers who has empty spaces. But the low side of that is we might not get everything as per our requirements, so we might have to adjust to what is available. Things like the floor space might not be in a symmetry that we would want. We might not be able to fit as many racks as we want. So that would take a hit on the kind of design that we have in mind. But in our journey, we have in fact done both. So we have done a brownfield, and we have done multiple greenfield deployments as well. And then once that is decided, and once the vendors are shortlisted, even before that, in fact, the location that plays a very important role in how it is. And we are an Indian company, and all our data centers are within India. And within India, there are certain pockets, right, where the data center business is really coming up, and that's where once it comes up, that's where all the other things also, which is necessary, for example, having a connectivity landscape, like having your internet providers presence, all the top tier one ISPs of India coming in, all those things matter. Then things like accessibility, how easily you can reach, because normally you would see data centers are always away from the city. It's not something, or would be right there. So you want it to be easily accessible as well. And then there are things like the seismic zone, which plays an important role as well. If you are having multiple data centers, you don't want them to be under the same seismic zone, for obvious reasons. So these are just top three I could think of, but there are a bunch of evaluations that we do. And to be so, in fact, if we have to look at a data center journey, if we decide to build a data center tomorrow, it's a good 2 year effort, where everything comes. For example, the one that we started back in 2020, and then we delivered it in 22, and that's a typical turnaround time for getting a data center. And then things like the scale, that is, once the space and the location and everything is out of the way, then you decide how much what is the scale that you're looking at, right? How many servers do you need on day zero, versus how many servers you would potentially have on day n, right? But the thing is, when you design a network in a data center, you always design it for day n, because you can't really there are layers in the network which is designed for the nth day, and it can't be changed, right? And things like cabling and connecting within between layers and stuff, it's all done on day n, so that when you scale from day zero, you just do a cookie cutter sort of a model, where you keep adding your pods and connecting servers, but the core fabric, or the core layer of the network, remains same, and it can take this additional the addition of servers as it would. And yeah, power and cooling is another very important aspect of a data center, and it comes down to what is a PUE, or the power usage effectiveness of a data center. And you would have seen everybody tries to get this. One is a golden number, but getting to one is not that easy. And basically, what the power usage effectiveness means is, how much power do you consume for your equipments, the complete infrastructure to power up, and does that exceed, and does it also include the power that you require for your cooling, your lighting? So when you say PUE is one, it means all the power that is there is only used for your IT equipments, right? Everything else, like your cooling and lighting, everything is powered by natural resources. That's where the sustainable data centers and like the experiments like Facebook and Microsoft, these guys have done, where underwater or in a very cold region they build data centers, is to get to that sustainable place, which will help them reduce their PUE. And finally, there's a hardware evaluation that happens, and this in itself is a mammoth effort, where it takes at least one and a half years for us to evaluate and arrive at what are those components that will fit into our design. And some of the things that get evaluated are the right, starting from the racks, to the storage, to the servers, the NIC, the network, and the optics, which connect all of these layers together. All each individual components we evaluate, we understand what's happening in the market, we talk to the engineering teams of all the leading vendors, and that's how we arrive at the final design. Right. So once all that is out of our way, what goes into building a network inside a data centers, and what are those building blocks within a data center? So, and this is where everything that we spoke about in the previous slide comes together, and then the lights on happen. So starting from the bottom, the white tile, as you can see, white tile is the actual floor area where your racks, your servers, your network get hosted. And once you get the handover of that space from the data center provider, then you start designing, and then you start fitting your racks, you put on your servers, then the network. But quite a bit of planning goes into how that happens, because that's where the symmetric approach that I mentioned comes into play, where we have a certain, we call it pods. Pods is how many servers will be there in one pod, and then the same is replicated across multiple pods. So that's how you manage a large infra, so that you don't look at everything as one. They cut down into smaller pods, and then that you just keep replicating. So on day zero, you might have three pods, which consists of, say, n server, x servers. Then when your requirement grows and you have the space to grow within the data center, that's where you add a fourth pod, and they all connect into the same fabric, right? So a lot of things that go into this white tile designing is, even within the rack, where do you place certain servers, a certain kind of servers? How will they connect to the network? The airflow is one of the bigger main components when you choose a server, when you choose a network, because of the cooling area and the hot air area. So all this gets decided, to the extent of, we even look at what is the bend radius of the cables, because if you look at DAC cables, they are thicker, so their bend radius is not as much as you would, on an optic or a AOC cable, because those are the fiber ones. And that also has an impact on how each rack will be placed, and how we can connect between systems in those racks. So once all that is out, that's when we rack and stack our servers, our network, and everything on all the racks. And then comes the fiber, or the fiber plant, as we call it. That's where you connect all these layers together, and we do a very deep evaluation. And fiber is one of the most expensive components in building a data center, the whole optic. It's a very expensive component, and that's why you have to really design it to meet your requirement and yet not be overboard with it, right? So that's why you have to take a choice of where do you go with optics, where you can go with DACs, because DACs are comparatively cheaper. So and the distance, the signal to noise ratio, all of those aspects come in. So there's a very deep evaluation that happens there. And once that is done, then these layers are connected between them, and then that layer adds up to what we call the data fabric. This is the core of the network, and this is where you have the leaf and spine, or the pods that we design. So each pod consists of a leaf and a spine layer, and each leaf is where, or a TOR, it's also called as a TOR. That's where the servers connect, right? So each leaf and spine layers, we have a math to it. They form a pod, and there are multiple pods, and they all connect to an aggregator layer, and we call it super spines. And that layer is what takes care of the intra-pod communication that happens. So that is where this core data fabric comes into play. And then that layer at top that I mentioned, which is called the super spine layer, is what connects to our edge fabric. And edge fabric is where you have, and one of the most important layers, because this is the entry and the exit point into the data center. This is where all the ISPs come and connect, and there are different types of connections that happen, which is the data center interconnects. You have your internet, the peerings, connecting to the cloud provider. Everything happens at this layer, right? And this is one of the most critical layer in the sense of the security as well, because what comes in and what goes out, it's very important for us to know. And that's where we have built a lot of observability as well, to understand everything about what traffic comes in and goes out of our network. And there's a strong emphasis on getting this layer secure and evolved as much as we can, and we are at it, as we speak as well. And then comes the WAN fabric. So this is the actual interconnects that come in, right? That's where we evaluate all the ISPs with the kind of requirements that we have. And we, in fact, we just don't buy bandwidth from ISPs and get done with it. With each of our ISPs, we work to make our setup very custom made, where we have the kind of redundancy that we need. We know how the connections happen to their POPs, how they have redundancy from their POPs to the backbone, and we invest in them to have multiple paths, multiple POPs, multiple exit points from the data center itself. So all this is part of the initial setup, and that's how. And this is paid dividends over the years, where we have seen outages where we have not been impacted, whereas customers of that ISP has been majorly impacted. So a lot of emphasis is there on getting the WAN fabric in a shape where it's highly resilient and redundant. And yeah, and then there's a management fabric, which is another important pillar. And this basically has twofold functionality. One is, this is how the whole bootstrapping of the network happens, network and the servers. So all the installations, and when they come in as a bare metal, all the image installation and everything happens via the management fabric. That is for the server side. But for the network side, though we use it for provisioning as well, but our main use case there is we build an out-of-band network there. And out-of-band network basically is for us to have a back channel or a backdoor entry into our network should our primary paths fail, right? So typically, if I'm sitting remote and I'm logging into one of our switches in some data center, we go via the VPN, right? We go via the public VPN, the company's private VPN and such. But that's the only path we have then, right? And then if tomorrow there's an incident where the VPN is down and the whole of the infra is disconnected from our data centers, that's where we have built this parallel setup, which acts as our entry point, and so that we are always connected to the data center. And in this as well, we take extra efforts to ensure the ISPs that we have though the ISPs can be same over there on our actual production network, but we make sure they connect to a different router, they have a different path, so that even if they face an outage, it doesn't impact the out of band. So we, in some sense, we try and make this as available as possible, so that there's always a path or an entry into the data center. And to power this all up, so once it's all wired and connected and lights on, you need to have an orchestration layer to bring this fabric up, right? Because you're talking about configuring 200 to 300 switches at once, and that's where we've built orchestration platforms. And ZTP, the zero touch provisioning, it is there in every world. It's there in the server world, network world, but it's one of the key features in today's era, because of the impact that it has. Like we can bring up this network in 10 minutes once we have all the orchestration in place and the logics set. And that's how that's how we bring up our network once everything is ready, connected. We just run our orchestrator, and then it lights up the whole data center. And then things like Ansible, which has, once the network is up and running, then you need to make changes. You need to ensure when you make the changes at the scale, they stay uniform, and you don't make random changes by logging into one device, making some change there, which might not reflect on a neighboring device and such. So that's why we use platforms like Ansible to ensure there's hygiene maintained, and everything is symmetric in that sense. And the final block would be the monitoring, and one of the most important blocks, because you build a data center, that effort is done and dusted, but the actual actual thing happens when you have to maintain that data center and operate that data center, and that's when the traffic, once it starts coming in and out, the onus is on the network engineering to know everything about the traffic that comes in and goes out, because we are the ones who have the complete view in that sense. Because everybody else, every other team would have a partial view of what comes into their systems, but that what takes everything into their systems is through the network, and that's where there's a strong emphasis on we having as much visibility as we can, and that's one area we have invested over the years, so that we know, and we are at a place today, where we really know what comes in, what goes out, and we try and we try and avoid any surprises there. And the main components there would be the flow protocols, like the net flow, S flow. Then there is SNMP telemetry for all the logs, and then there's syslog and such. So it's all the fundamentals, the core networking protocols of monitoring that always existed, with some evolution that has happened. But there are good products that are there in the market that we use, as well as we have built things in house. Like one of the things that we have built is to measure latency, that is end-to-end latency, where we send a packet on each hop till the destination, and then we get to know the latency of each of the path, and we use that heavily on our inter DC links to understand what is the latency that we are getting from each of the ISPs. Many such things that we have built, some things we have bought, but yeah, in summary, we have a very strong emphasis on observability. Right. So once everything is there, and what happens in, right, and that's what I'm trying to project here. This is how the flow of traffic would be from a Flipkart user. You go to the app, you go to the web, you come all the way from internet. It comes to our edge network that I spoke about some time back. From there, it runs into a fabric. A fabric does the horizontal scalability, horizontally scalable. So it looks at the load balancing and make sure it goes down to our proxy layer, which is where, which is again horizontally scalable as required. And that's from there it goes on to the real server, which is where the apps are hosted, and then the return path is on the same lines. And yeah, so this is how a very high level or 10,000 feet view of the traffic flow would look like. And even in this, we have made a lot of investments in the area. Like we have done our own traffic engineering for we call it EP or egress peer engineering. So one thing that we try and make sure is, if a customer is coming from, say, a geo network, right, the return traffic of that customer will also go on geo network, and in that sense, we try to improve the experience of that customer, so that he does not have to take another path, and that could lead to added latency or some sluggishness. So that is one of the areas that we have invested in, and like this, a lot of. So over the years, we have understood what kind of problems exist in, and that is more so for the when we are looking at things at a scale like what we have, where we have so many thousands and on a flash sale day, within a second, I think we hit 100,000 requests and such, right? So when we get to when we get such a view of the traffic that comes in and out, that's where we also get this opportunity to improve and make things better. Yeah, I think that's what I had for today.
This opens up a whole bunch of stuff. There's quite a bit of private chatter that has happened and some questions in public. I'm going to begin with I think is a simple question for you. And we'll begin from there and we'll sort of slowly build out things. So Anant left a remark that if there's a new organization that is looking to build an India or a Bharat scale application, what would be your indicators around when they should move from cloud to on-prem? And you started off your thing by saying that this is not really a cloud versus on-prem, because even though you're predominantly on-prem, you still have a public cloud presence, small as it is. But the question of indicators is something I found very interesting. And if you have any remarks or indicators that you want to bring forth, please go ahead.
Right, and I think it comes out by itself. That's how I would say it, right? Like when you're on cloud and when you're scaling your business, right? You know how much you can scale, and and to be honest, in India, the ecosystem or the cloud ecosystem is still growing, right? You don't have the kind of scale a public cloud might have in US versus in India, right? Because they're still building, and India as a data center infra space as well, they're building, they're growing, right? So even with the whatever has been built today, it's not enough for big scalers or hyperscalers to come and run all their workloads from there, right? So as you grow, as your company grows, you yourself will get that indicator saying, okay, this is we have hit some threshold, right? Things are not growing here. We are not getting the kind of the compute or the kind of storage requirements that we have versus what is available. The kind of offerings that are there, platform offerings that are there, may not be in line with what you expect. And the regional thing also, right? Maybe you want to be hosted out of a certain region, but when a cloud provider builds, so for example, if there's somebody in India and he has two regions, one region would be a smaller one, other one would be a bigger one, right? And maybe you that is causing a problem because you have a very latency sensitive application that you're building, right? And that's where you choose, okay, I need something very close to my customer base as such, right? So I think this evolves out by itself. When you actually go into a cloud, if things are working fine, you wouldn't think beyond. And then cost becomes another thing, right? Even when you do a scale as you grow kind of a thing, right? When you start paying those hefty bills, then you might want to take a pause and see, oh, is there a better option, right? Because what we have seen as cloud is expensive. Yeah, I mean, with all the pluses
Yeah,
that may come.
and
Yeah,
I think it's even more interesting because in a lot of the cases, I believe that the hyperscalers do are not paying the rack rate. There's a discounted rate at even at that discounted rate,
yeah,
your growth basically makes it quite expensive to maintain
yeah.
it
True, true,
workloads
true.
on the cloud.
See, discounts are there, right? And even with the kind of and I, if I have to give some random thing on how it has been for us, it is like 2x to 3x difference,
Yeah,
right?
yeah.
In terms of the cost savings that we get, right? And the multiple factors that get calculated, and we arrive at how a compute instance for that matter on a cloud provider versus being on our on-prem, and what is the cost to run that compute, right? So that's how we do the TCO, and we have seen 2x to 3x is a difference that we get.
Yeah. So I mean, I think what could be taken away from this small question is that there is the sweet spot of scale and growth till which you can gain benefit out of whatever cloud infrastructure you're using. And at that, beyond that, depending on how the rate of growth you are looking at, you seriously need to look at the economics of it. And in fact, it's also kind of interesting. Like there's a whole business of cloud economics and
Right.
cloud economy where the focus is on optimizing your cloud cost. So it basically kind of
Yeah.
implies that in default configurations, you are likely to burn a nice little hole in your budget by just
Fully. And
using cloud.
right. And the like the essence of that is infrastructure end of the day is a cost for a company, unless you are an infrastructure company yourself, right?
Yeah,
Like it's a cost, right? And then that's where you would always want to weigh your options and see how you can optimize it.
there's another question that I'm going to wait on because I have something that I wanted to ask Purvi in terms of the one of the things Purvi you mentioned that and Varun also reiterated this that the time to market is one of the key things that the choosing to go to the cloud is a benefit, and hence a lot of the early stage companies and even mid stage companies continue to be on the cloud. If I go back and read some of the reports that have come out of the big cloud providers or even the consulting research group, the three big reasons why people say that they are trying to move their workloads to the cloud are revenue growth, future proofing of business, and reducing overall costs. Uh, Now, this is an interesting, very equal split. I mostly see if I go and look at it. It's whereas Ideally, one would say that looking at how you described that some of the more advanced workloads are getting onto the cloud, AI, ML, and the other edge computing pieces, one would think that future proofing would have more uptake rather than this almost equal 30-30 split of stuff. Do you think this also reflects how you are seeing as in your engagements that people are such kind of balancing all these three big goals in terms of when they take decisions on between cloud and on-prem?
Uh, well, definitely. See, this is how we see. If it's a medium or small scale business, which you pointed out, definitely, if you say time to market reduces when you go on cloud, right? So obviously, you can see the revenue generation. I mean, it's a fast process for them if you go on cloud, right? But at the same time, there are other factors that needs to be considered, like see, not just setting up infrastructure comes with a cost, maintaining it needs an expertise, etc. So that is one factor. But apart than that, if we see on the other side also, there are companies which are very particular about, they don't want to be vendor locked, if I say, right? So that is one of the factors. But again, when you think about getting vendor locked, there also we have various options, right? You go on cloud with a strategy that you do not lock yourself to a vendor. Your architecture is designed in such a way that today you are on certain infrastructure, and tomorrow if you want to make a move, how you build that entire system that you don't have to uh, you know I mean, it becomes an easy task if you are if you have thought or you have some thought process for future perspective, then it becomes much easy. But yeah, there is other set of companies we have seen who do not think on those lines, and right now their focus is that how we just reduce our time to market, build our application quickly, launch it, start growing. So that is how I see. uh,
Yeah, so I think this is also interesting because up until 2021 or so, or early parts of 2022, in most presentations and in discussions, the numbers floating around by various experts was that there is only 25 to 30% of mission critical workloads on the cloud, and there's this huge workload that still remains to be migrated. So, which means that there are, to me, that kind of tells two things, right? That the one, there is more work remaining to do. The second thing is also there is an opportunity to examine whether those workloads really need to go on the cloud, or whether there can be a hybrid model that can be done. But in terms of mission critical applications, there has been a reasonable more adoption of the cloud pattern, isn't it? In terms of like moving workloads that have traditionally been in the data center, have been mission critical to the business, and then moving them to the cloud. Is that a correct formula, correct hypothesis to have, or do you think that there's still like it's low numbers and there's more numbers remaining to happen?
Definitely there is more that's happening as you go ahead, right? uh, there is a new concept which is emerging, I should say. um, how do we call it? It's enterprise specific cloud services, right? So when you say mission specific, that is where I see that nowadays there is another market that's growing up. That means the infrastructure is being the cloud these big cloud providers are moving towards the capability of providing an infrastructure which is focusing on your uh, uh, industry specific, I should say. If you come from, let's say, health domain, or you come from fintech domain, people who were more hesitant to move towards cloud, so they are nowadays building the infrastructure which is more specific to a certain sector. So that is one thing. The other thing is, if you remember, I called out the uh, uh, sovereignty of data. That
Yeah.
is another thing, right? So with more this area becoming more mature, it gives more room for those hesitant organizations to start thinking about those hybrid models. So it is still growing.
Mm. Yeah, interesting. I mean, like I mentioned at the very start of this conversation, that the entire, if I just go by the what I read in the press, it would seem like everybody is just hell bent going for it. But if we sit down and discuss this and unpack some of the variables and try to understand some of the dynamics, it is fairly obvious that this is a slow, steady progress, bringing in areas, let's say, of data governance, compliance with regulations. You mentioned data sovereignty, data locality comes in. And the fact that you also need to have, there is this trade-off, right? If I go back and think about what Varun just walked us through, it's a hell a lot of things to build from ground up. Whereas if you are taking somebody's services, you are basically kind of abstracting your team from a whole bunch of stuff. You still have ownership of actually ensuring that the business reasons and business strategies out of the deployment come out. But yeah, I mean, going back, the Varuna track pretty much pulls back the curtain on how the infrastructure would work, and tells us that walking down that path means there's a hell of a lot of investment that needs to be done. And on that, Varun, I have a question for you, which I actually have two questions, not both of them not are specifically for you, but one I'm going to ask you to begin with. So you showed a whole lot of backend stuff, and obviously in those stability would be a big contributing factor and has a major role. So are there specific ways in which you select the components, hardware and software, that builds out your stack? How much, if possible to say, of your stack is based on open source software? And how has your experience been having had open source components in your stack, if you do have them? And I'm guessing you do have.
Yeah. Like across Flipkart, yes, right? Like a different layers. Once you once you build the network, then the services are done on top of the network, right? For example, the proxy service that we run, right? We built it ground up again using open source to customize to our needs and such, right? And likewise, a lot of platforms that we have are built on open source, which is customized to our needs. So we have a strong, when the build versus buy argument that happens, right? So it's very much driven by the fact that if we can build, if we have the time, we would rather build, because we are a very technology focused company, and that's why we have, we have always been trying to be ahead of the game in building our infra, so that, we know what is happening in the world, and so we can get closer to that. So that's always been the drive, right? And only areas where we find real value in buying something, or if it is, something that we need tomorrow, we don't have it, we might go ahead and buy it, right? But the company as a whole, we focus on building as much as we can, and that's why we have like I think 1,000+ engineers in our org, right? So yeah.
Okay, I think that kind of gets us to a part answer of the other question that was there, which is about, with the rise in popularity of open source orchestration systems, do you still think there's a lot of value in building your own tooling? And ideally, companies would love to have the capability to run their baseline workloads and data centers they own and scale into the public cloud to meet demand. Can you outline any obstacles you have faced in the hybrid cloud journey? Yeah, this is an interesting one. Obstacles, obviously, there's going to be, I wouldn't say obstacles, probably challenges that sequentially in a phased manner you'd have to tackle and create plans for and mitigate the risks. It's at the end of the day, I think it's all about mitigating the risks that is involved in the plan, right?
Well,
So, but
I'll tell you one out and out thing, which is a big obstacle, right? And
okay, go ahead.
that is, when it is a hybrid thing, one half of the side is not with you, and that's a very big obstacle, right? When everything is in your control, that's the beauty of, either everything is in cloud, it's fine. You just give it there and wait for good things to happen. If it is in you, if it is with you, then you try and make things happen. But when one leg is there and one leg is here, we've seen that, right? So that if I have to really say what is the biggest challenge in hybrid, that would be the challenge.
Uh, this also reminds me that you mentioned that as one of the things that being on the public cloud means that you're as a customer, your experience is often not of the highest quality because you might be raising a ticket and you're waiting on cycles to be processed, resources to be allocated, engineers to take a look at the problem and eventually get your solution. Is this the general is this the general customer experience across public clouds, or is this more of like uh, because of the scale, you have more interesting, challenging problems, and hence this becomes more like bespoke engagements?
Right. No, I mean, I wouldn't generalize it by saying, that's how the experience is. But like I said, it's more about, some things that you can resolve if it was with you, but it is not with you, right? So you have to have that wait time, and you have to go through the process and stuff so that it happens. So operations always, when it is with you, it's different, and when it is not with you, you really lean on somebody else, right? So I think
Yeah.
that's the thing with anything for that matter, right? You would
No,
want.
true. True. I mean, so again, coming from the perspective of uh, as a scaled high transaction and high throughput customers, you'll have SLAs that are not they're not templatized in terms of how other smaller companies would have.
Right.
And I'm coming from that perspective that even with all of those mitigating risk mitigation plans in place, so that if you still see that as one of the friction points, you obviously see that as one of the friction points because your business strategies and your business operations are getting hampered. It does mean that some of the ease of use parts that are often talked about cloud computing and public clouds do not necessarily reflect in the day-to-day. The tactical part of it, you do have situations where you stumble and you end up having challenges that needing to be addressed. Okay, I don't have, what I did was, unfortunately, I collapsed some of the comments that were similar into questions just to ensure that we don't make it into a massive Q&A session. This is interesting because on one hand, how Purvi sets up the conversation, it is all about the fact that companies over a 3-year period are slowly moving their workloads. They are moving some of their exciting workloads, newer workloads to the public cloud. You, on the other hand, Varun, you are mentioning that one can absolutely do that, but you reach a point in your growth cycle where you realize that you simply need to have more control compared to ease of use and ease of functioning. And at that point, you really have to go back and think about how you build the control and the entire stack from ground up.
Right.
And hence, I think the hybrid thing. Now, I'm going to ask both of you, and you can take it in whichever order you want to do. Do you see hybrid as something hybrid in terms of not just having in two clouds, which is one definition of hybrid? The other definition of hybrid, you have on-premises and you have clouds. Do you see this definition, on-premises and clouds, continuing to be the design pattern that sustains in the next 3 to 5 years as more and more of this more compute intensive workloads start becoming normal?
Sure. Yeah. So yeah, I think yes. I think it will be driven by business, the kind of impact, the kind of scale that one has. But having said that, I think to your previous point, right, the cloud. I mean, the kind of investments that are going into the cloud providers by themselves, right? So they're really maturing, and in terms of the feature set, in terms of, I mean, it's a very big competition that happens between the three big providers, right? And everybody wants to have those big companies come to them to that shows their worth as well, right? And then that's where they also learn what happens at scale, right? So if for example, if a cloud company is running 10 customers of small size customers versus running one with scale, that cloud company might evolve sooner because they understand bigger problems now, right? And then that opens up more avenues for bigger hyperscalers or bigger bigger companies to come in, right? So I would say it's in that sense it has really matured because our relations with cloud has been for over many years now with multiple partners, right? And we have seen that evolution where things have really improved as well, right? Where a lot of things have added a lot of value, and hence we are still there. I mean, that's how I would want to say it, right? And so yeah, on a day-to-day basis, it is good when something if an incident happens, that's where people come together, and more often than not it's something new because it's a scale, right? It's not some a known thing, because if it's a known thing it gets resolved faster, right? But if it is something um, unknown versus on a bigger scale, the impact goes up, right? And that's where people, it's a continuous journey, I would say. It's a learning and moving forward kind of a thing. So to your question, yes, I think it will be next 3-5 years. I don't see this going away anywhere. The on-premise, the companies who have been traditionally building the data centers, I would still think they'll see value in doing that, and they're spoiled for that choice that they had, right? And if the business supports them, and because that's a cost, like I said, it's a cost, effort, money, a lot. I mean, a lot of things comes into that, right? So if the business is there to support that, I would say it will continue.
Would like to hear from you about this.
Definitely. So Shankarsan, like you mentioned that it's not just two clouds, it's like on-premise and on cloud. So actually, we call it hybrid and multi-cloud. They are two things, right? Multi-cloud is where you leverage these services from various cloud. You want to sit on one cloud for certain services, on another cloud on other service. While there is another model that is hybrid, where you are a portion of your application sits on premise while other part in or I should not say application, actually a part of your system sits on premise and while other part on cloud. So this is how I see why don't you leverage the best of both worlds, right? It's like as the systems are maturing more, right? You have dedicated connections provided by cloud providers nowadays. So that is one of the benefits companies can have. Specifically, the people who are hesitant moving to clouds are people who have they don't want to put the data in cloud, right? Data is one of the reasons why people are hesitant moving towards the cloud. They don't want to keep their data on a public cloud. They want to manage it in their own on-premise infrastructure. Fair enough. But what about compute intensive applications, right? So if you have some applications which require a lot of bandwidth, they require a lot of heavy infrastructure to be built. So while keeping the portion of your system on your something that is more, that requires more regulations or compliance related security, I should say, they can sit on premise, while other portion of it can still leverage the benefits of cloud. I'll again circle back to the same thing. Nowadays, people are moving towards artificial intelligence and machine learning, right? It requires a lot of bandwidth. It requires a lot of high computational servers. You can design your application in such a way that you can leverage the power. These cloud providers are doing a lot of innovations on the artificial intelligence side, right? And if you want to move in that direction, doing everything on premise may cost you much higher, right? So that is the area where you can start utilizing the benefits provided by these cloud service. Also, something related to your last question, where you don't have control over when you put something on a public cloud, like Varun mentioned, that you don't have control over a portion of your application. But this is how I see in a different direction. The cloud has now matured to a level they provide 99.999% availability. Right, that is what they claim for. Plus, for their high-end customers, they have a very quick turnaround time. Right, so with them claiming availability and turnaround time to that extent, I don't see that these organizations would anymore be hesitant to move on hybrid model, right? That is the safest way to go. Like you are getting the benefit of leveraging all the new features provided by cloud, as well as you are able to take a control over the data or the portion of your system which you don't want to put on public cloud.
Thank you. Well, this has been interesting in terms of this actually pushes some of the agenda points that we have in this project for the coming months. We do have plans to pull together a conference about cloud architecture patterns in the month of March. So do subscribe to this project on the RootConf page at hasgeek.com. Next month, 16th of February, we have Prathamesh talking about the hidden costs of instrumentation, which I would, to all those who are participating today and will be listening to this recording later on, I would highly encourage. Prathamesh of Plus9 has been doing a whole bunch of work. And as you would have noticed in today's conversation, observability, instrumentation, all of these are some of the critical elements in management of cloud in your infrastructure, regardless of whether you're on-prem or you're on cloud.